Hi everyone, my name is Aisha Rina Ibrahim. Today I want to explain to all of you what the task that I do for the assignment data driven fuzzy membership function using statistical approach method. So the task that I do is I need to subsample 100 instances from the data set that we found for our project, and I need to avoid bias while performing subsampling. So before I start, let we see our data set that we have. Okay, this is our data set. Okay, our data set with the data, it start from it start from 1 January 2010 until 1 January 2014. Okay, our data set have 1,462 rows. So we can see. Okay, we need to sample 100 rows from this data set, so we can do in rapid miner. So let's start. Firstly, we need to open the rapid miner. So this is interface of rapid miner. So before we start, firstly we need to import the data. So we import the data, click my computer. So we find our data set. So with the data and click next. And the data set not have any problem, so we can go to next. Go to next and click finish. Okay, this is our data set. It has 1,462 examples. So let's redo. First, you click design and you drag the data set with the data to the process, and then we need to search for operator stratified. Yes, this sample stratified. So we drag to the process and we link. Okay, so at the sample size, we need only 100, so we can put the number 100. If we need more, we can put number more. So we link and we run. So this is the data set. New data set is 100 examples. So we can see it's 100. So this is 100 row now. So now we want to create the new data set in CSV. So we can search in this operator is write CSV, and we drag. Okay, then this we can search. So weather data.csv open. So this continue and we search write file. Okay, this. Okay, sorry. Village. This village weather data.csv. So data.csv and we click run. So now we see at new see the file is have new file is weather data.csv. So it is the output from the rapid miner have 100 row. So we can continue our task, which is give a simulation on your Slack fuzzy membership value assignment method using the subsample data, and it will be continue with Farid. That's all from me. Thank you.
Okay, so after we sample 100 data, then we will find a plot for the database that we use. So here is our variable that we will use to represent the database. So we need to execute the file. So the file name is assignment. Just enter and wait. And here at the workspace tab, you can see that the database, the 100 times 9, there are 100 row and 9 column. So we will use the precipitation column, wind, relative humidity, and solar. So first we will see the step plot for the database. You can see at the common window, it will generate automatically. As we can see here, there are a line graph. You can see the value of each by precipitation, wind, humidity, and solar. You can see the value, they are up and down. Then we will see a scatter plot between two columns. So just type scatter and then open bracket. Just like first, we have declared the variable for the database, that is a weather, and then we need the column name that we want to use to compare. So first we will use the precipitation column, and we will, for the others, we will use the column. And then close the bracket. And hit enter. Then a new window will pop up that show the scatter plot. We can see their mean and standard deviation just by click on the toolbar and choose the data statistic. There will be a new window pop up. Here we can see that X is the precipitation and Y is wind. So we can see the precipitation mean, max, mean, median, mode, standard deviation. by clicking the mean, we can see at the graph there are green line that show the mean for precipitation, and then when you look at the max, you can see a blue line that show the max for the wind. You can also see the mean shown, the mean for the column wind shown in the graph. And then you can see for the other plot, like between column wind and relative humidity. As we can see, there are pop-up window, and if you want to see their mean, just click the toolbar, apply the statistic, and you can see the mean. For the x is wind and y is relative humidity. So you can see the mean for the wind is 1.862, and as shows in the graph, there are green line, and the mean for the humidity lastly, we will see a scatter plot between precipitation and humidity. As you can see in the graph, they are close to the left side. They are more on the left side. So we just see their information given that x is precipitation and y is relative humidity. So you can see that the mean for the precipitation and relative humidity, they are crossed here. Then you can see the t-test for the precipitation between precipitation and wind column. So just use the t-test 2 and type. You can see the answer given is 1, mean is a true. It's a true. Then t-test for the precipitation and the humidity, also true. And t-test for the wind and relative humidity, also true. So you can see that the relationship is true. So lastly, we will see the membership function for the database. We will use the fuzzy command for the fuzzy toolbox to appear. We already have done the fuzzy membership, so we just input and profile and choose the file. We can see the input. We have 4 input that which we use for the precipitation column, wind column, relative humidity, and so on. We use Mandani process, and the output is we are going to predict whether it's rain or not. So this is a variable for precipitation. As you can see, there are F3 membership function. They are low, medium, and high. We are using Gaussian membership function, and for the rest input also we are use Gaussian. So for the win variable, they are also low, medium, and high. Variable relative humidity also have low, medium, and high. And lastly, variable for solar, we have cool, and hot. So the output, we have three output, which is rain, cloudy, and hot. Okay, and then close. Let's get at the rules. I will explain just the three main rules, which is we can predict rain, predict not rain, and predict cloudy. So if you want to predict rain, so the rules is if precipitation is high, wind is high, humidity is high, and solar is cold, then it will predict it rain, it will come rain. So for the second rule, if the precipitation is low, wind is low, and humidity is low, and solar is hot, then it will predict hot or not rain. So for the third rule, if the precipitation is low and wind is low and relative humidity is medium and solar is cool, then it will predict cloudy. So we can also give the input by just in the frame, just click the view tab and click the room, so it will open a new window that show this window like this. Then you can adjust it, just the red line. So let's say we set the precipitation to 5.68, and for the wind 0.1 maybe, and relative humidity 0.2, and solar we are just using 8. So the prediction is 0.497. So we can also put it manually by using command. Red fish is for to read the FIS file that we just create. So just type the command redfish and select the membership, select the membership function file that we just do. Make sure it is .fis, and then as we can see at the workspace tab, there are new row that comes an NS that we just use for to read fish. So for the evil fish, is for we to put it manually. So we just declare evil fish from bracket. We put the file name as shown at the workspace. If we use the others, they will not read it, so we just use the workspace. at the workspace tab. It show ANS, so just we use ANS and we open a bracket. We set it at maybe some 20 for the precipitation, and for the wind we just put 3, and for the humidity we just put 0.9, and lastly for the solar we just put 11. So we close the bracket and just press the enter, and we show the result given is 0.4113. This means it will predict rain. 0.4 it will predict rain. So that's all for us, and thank you.
Hi and good morning. My name is Azira Fazrina binti Aminuddin. Today, I would like to explain the assignment that have been done by us, which is rainfall prediction using statistical approach. So, we need to know what is statistical method. Statistical method is about mathematical formula that used in statistical analysis research data. However, there are 5 steps in data-driven method in our project, which is generate initial prototype, refine generate prototype, generate initial MFS, which is stand for membership functions, remove unwanted MFS, and the last is refine generate MFS. These steps have been used to complete our project. So, our project is about prediction of rainfall using statistical approach based on the data provided, such as mean and max temperature, humidity, and others. By using the data, we hope to be able to predict the rainfall. Our project has been done in fuzzy logic, where have been main difference between fuzzy logic and classical logic that fuzzy set using for membership variable. In fuzzy logic, we know that have the advantage over classical logic in area like artificial intelligence, where simple true and false statements is insufficient. We know that human good recognizing by eyes, but computers are better at counting and measuring. Fuzzy logic helpful in guiding computer to find the right things to measure and calculate. So we use fuzzy logic in our project based on statistical approach method using data-driven step. So that's all from me. Thank you.
Data-driven method for generating unstable membership function. For our system, we use a trapezoid membership model. Here we can see the membership function can be expressed by the formulas. And to make this system, we have 5 steps. Step 1, generating initial prototype. We select 100 sample randomly, and that means random 100 days. For this, we use attribute wind, precipitation, solar, and relative humidity. Therefore, to generate secondary phototype, partial data is quite different from the mean that need to be determined. Based on the input, two values can be expressed as x1 and x2 by using this formula. Then we set the predetermined critical value. If the value is higher than critical value, then the hypothesis is null. Step 2 is refine generate prototype using system formula. Then by step 3, we generate initial membership function. To the step 4, we remove and combine the unwanted membership function. By using a symmetry of membership function, we can define by this and the result. Scatter plot with session and wind and relativity and precipitation, and the overall graph. Thus we get this value, the mean, and max and standard deviation. The rules and the conclusion. The conclusion is that rainfall prediction system is important for agriculture sector because for farmer, weather is the main important factor in producing a good crop and production.